Hi, I'm Derek, and today I'm going to be bringing you on a little bit of a journey through CQRS and your controllers and slimming them down if they're getting a little big. So everything I'm going to be talking about today is on my blog at codeopinion.com. I have a series called Fat Controllers CQRS Diet that outlines most of what I'll be talking about today, as well as his code samples, and we'll see that in some slides here coming up. So first, a little bit of context. I think it's important that I give you some context about the problems that I was trying to solve and how CQRS helped alleviate some of those issues that I was having. So I just really think it's important that you kind of understand where I'm coming from, because I don't think this is just a silver bullet. I don't think CQRS solves all life's problems. It solved some problems and parts of the applications that I was working on. I don't use CQRS everywhere. It's applied appropriately, and what I'm going to be talking about today is where I applied it based on some of the issues that I was having. So if we jump back several years ago, I don't want to say when because it will make me seem incredibly old, is I was working in a distribution company, and we had a warehouse similar to this, and I worked in the on the office system that was primarily used for order entry, customer service, and a little bit of the warehousing aspect of getting the orders out to them so that they could pick, is what they call picking the product, to pick the order and ship it out, etc. So some of the warehousing aspects, order entry, and customer service. So the internal application used in the office was a WinForm application. And this goes back many years ago, but those were the aspects of what that application covered, and it was a .NET WinForm application. So over time, in the mid-2000s, we had a customer-facing, I shouldn't say customer-facing, it was mainly used by internal sales reps that were across the country in Canada. So it wasn't completely public facing, it was more for our internal sales reps. There were thousands of them across Canada, and they were using a PHP application at the time to enter their sales orders. This was a completely separate application, and daily orders would be converted from the online system database and converted and imported into our internal application, and then they would be processed from there within the WinForm application. As time went on, we realized that it was going to be best suited for us, because of wanting to do some code sharing, to convert this into an ASP.NET application, MVC. So as that started happening, it really got no better than what our PHP application was, because essentially we didn't actually end up having a lot of code reuse. There was still completely two different code bases, and although they were different applications, behind the scenes there was a lot of duplicated just business logic, etc. And I'll start to go through some of the duplicated code and what some of that code was. So whether we're talking about the controllers or whether we're talking about WinForms, this applies to essentially both and some of the code duplication that we have. The first was authorization. This was the least amount of duplicated code, because the actual MVC application, because it was used for our inside sales reps, it was a different kind of permission role structure than it was for our internal application that was used, say, by somebody in the warehouse or somebody in data processing, data entry. So authorization wasn't completely duplicated, although there was a lot of commonalities between it. Then there was data access. So we were primarily using ADO.NET to MySQL, and again, these were two separate databases entirely for the MVC and the WinForm. Although some of the schema was similar, majority of it was similar, there still were differences. So we had a lot of data access in our controllers and our WinForms, and that was just straight ADO.NET. There was a lot of data validation. So on the MVC side, it was validating incoming put or post requests, query string data, etc. And then on the WinForm side, it was a lot of just the form validation, etc., the data coming in, what you would typically expect. And here's the big one, was our business logic. The way that the application worked in terms of order entry was, over time, our MVC application and our controllers developed, especially when adding products, and it really revolved around the products and the prices of those products. And at any given time, it was kind of a month-to-month basis where a product could have a price in January that was a certain price, in February it could be a different price, and there were a lot of variables in the mix as well as what else was on your order. If you had a certain total of an order, then you could purchase certain products at a certain price, or 50% off, or 75% off. There was different rules that were created month to month to month, as well as new products being added, some being discontinued or on clearance. So each month we had to, in the middle of the month, create all this new logic, get it all thoroughly tested. And what ultimately happened was, because the internal data entry in our WinForm app was being used less and less for order entry, most of this logic simply was living in the MVC application. So when we start talking about fat controllers, ours were getting massive because they were containing essentially all these responsibilities. So exactly this. Our controllers had way too many responsibilities that were mixed and tangled together, and there was no way that in the current form that we were going to be able to, what our original goal was, share logic and share code between our WinForm application and our MVC application. So what we decided to do was, enough's enough. Let's do what the logical thing was at the time, or seemed was at the time, which was advocated, which is to layer. So we decided that our MVC application we were going to start with, and we were going to separate the authentication pieces. We were going to remove a lot of the logic and the business logic into a business logic layer. And then all our ADO.NET code, at that time, we were going to separate into a data access layer. And then all that would sit in front of our MySQL database. So this seemed logical to us. A lot of what we read at that time was talking about layers. So we decided this made sense, because what we could do is we could just ultimately have our MVC application be sitting in front of these layers, just like our WinForm application, and they'd be sharing the rest of the layers that we were creating. So when we really take a step back and look at this, really ultimately what we were trying to do was minimize the coupling to a framework. We were trying to minimize our coupling to MVC, and we were trying to minimize our coupling to WinForms. And the reason is that, yes, we had responsibilities mixed up, and we could separate those by layers, but ultimately, in our MVC application, we were using a lot of dependencies that were specifically from MVC, such as the HTTP context, sessions, etc. That was littered through all our code, which was within our controller. So extracting that was really painful as we started separating things out into layers. So what I want to do now is, I guess, talk a little bit about what these layers looked like. And if people, again, I just want to describe these things in a somewhat, hopefully, a generic way, that you can relate them back to your own application. If you're doing these types of things, if you are, then as we get going, you might find some benefit to the approach we're using now. So in our business logic layer, this would be something very typical. This is just a made-up example here, but if we had the concept of a product, which in our case would ultimately just be a POCO that represented a table in our product table in the database, with maybe some extra properties, etc., for different calculated fields, but ultimately there was no behavior on it. Our behavior resided in some type of manager. So whether it be a product manager, a customer manager, an order manager, whatever entity there was a manager for it. And that manager would often take the POCO, the product, and manipulate in some way for which should ultimately call the data access layer, do lot related to logic. A lot of the business logic was in here. So this would be pretty typical. We would have a product manager that would have things like add a product, update a product, delete a product, maybe more specific action-oriented things like increasing inventory, decreasing inventory, something of this nature. And this is a very small example, but these things would turn out to be dozens and dozens of methods related to the actions that could be formed on a product usually. So let's jump into what something in our data access layer would look like. We would have, in the same type of notion, whatever entity it was, we would generally have a repository for that entity where we would keep all the data access for doing the queries or inserting data, updating, whatever the SQL statements were that we wanted to perform were contained within a repository in that layer. So when we talk again about our product entity, we would have a product repository that would have generally the basics of the insert, delete, etc. And then just a pile, a lot of methods that were for querying in returning an individual product, a list of products, whatever the case may be. This would get really out of hand because what they would ultimately turn into is very fine-grained ways of querying that particular table or whatever that query was. So you can see that I have a find by name, find by SKU, and then in just a straight find that has more arguments that kind of limit the way that the query is being performed. And it seemed like anytime somebody needed to add a new specific use case, they could never really use one of the existing methods. So a lot of times these methods were only ever used in one place. It seemed like they would get added without, there wasn't a lot of reuse between these methods. And if we were going to end up, I don't have the example here, you can kind of see the one with the find kind of gets it there with limit and paging. They would end up being so dynamic, then it kind of lost the point. So there were two major pain points we had when we started moving to layers. Our objective with starting this was code reuse, and that we wanted to be able to use the layers so that we didn't have everything in these massive controllers that we were developing, as well as in our WinForm application. So the issue here was our two applications were not a one-to-one. They weren't doing the same thing exactly. The MVC application was like I said, a front end for order entry for our inside sales reps. That was predominantly it. The internal application did a heck of a lot more than that. It was a much of a larger project or an application, and like I said, it did a lot of the warehousing, interacting with our shippers, the shipping companies. It did a lot more than just what the MVC app did. The MVC app was much more of a smaller subset of that. However, it turned into the predominant place where order entry was now happening. The other main pain point was just making a simple change. Making simple changes became painful. That if you wanted, a small example of this is if you wanted to add a new piece of data, whether it was just something, a column on a table that you were adding, the number of layers and files that you had to work through to make that happen was cumbersome. So let's take a look at how that would actually look and see if you can feel the pain here. We would have to go back into our POCO, our data model. So we'd be in our data access layer. And we'd have to open our product model and add the new property in there. We'd be jumping to the product repository. We'd have that file open because we needed to adjust any queries or insert statements, whatever that we were dealing with for that. We would then be looking in our product manager, which if obviously doing some type of business logic on it or validation. So we have that file open. We would have our product controller open so that we can continue passing data through from however it got to us via query string or post data, etc. And then not to mention, which I don't have listed here, which is the actual view end of it, whether it be our Razor page or our WinForm or wherever it was, a report, who knows, that would also be in this list. So at a minimum, I had 4 or 5, likely more than this at the time, files open for just adding a new single piece of data. It's pretty painful. So how did we get away from this pain? And it was actually, it took a while for it to happen, but it's when we discovered CQRS. So whether you are using CQRS, whether you're not using CQRS, if you've just heard of it, I want to use Greg Young, who coined the term. This was on his blog. I just copy and paste from him. I want to get this out right off the bat to explain what CQRS is, because I think there's a lot of confusion behind it. So CQRS is simply the creation of two objects where there's previously one. The separation occurs based on whether the methods are a command or a query. The same definition that is used in Bertrand Meyers in his command and query separation. A command is any method that mutates state, and a query is any method that returns a value. It's really that simple. Whether a command is mutating state in your system, a query is returning a value. That's it. We're not talking about anything other than that. That's the simplest form of it. Having separation between when you're mutating state and when you're just querying and returning values. So I'm going to pick on a code project article that if you search for CQRS, you'll stumble upon this article. At least you could a couple months ago. It was high in the search results. And I'm poking fun really at this diagram because I've created this diagram or a similar one early on when thinking about CQRS and trying to get a gist of what it was, because so often CQRS is described along with other patterns or concepts, etc. Because it works well together. People often do these things with other things such as domain-driven design or event sourcing, but CQRS is neither of those things. It's often used with them, but it's not them. So when we look at this diagram, yes, it is doing CQRS. There is a separation between commands and queries, but that doesn't mean you have a domain model. That doesn't mean you have an event store. That doesn't mean you have two different data models. That doesn't mean you have a command bus or an event bus. It's again going back to it's separating reads and writes in kind of the pipeline of how you're taking those requests. So again, it's not this. It's as simple as just separating mutating state from queries. That's it. So let's jump back to the kind of layered diagram that I have with our MVC application, and we have our layers in the mix there, which is our authentication, business logic, and our data access. And really what I want to do is I want to get rid of these layers, and I can do that with CQRS. So how do I do that? What do I visually think of that like? Well, it's really simple as me for it's just replacing them entirely with whether I want to mutate the state of the system or whether I want to query the system. I'm just really thinking about those two ideas at this point. That's not to say that you don't have layers per se or shared cross-cutting concerns, and you will, but just as a basic concept here, that's really how I'm thinking of things. So then you might think, okay, well, if I'm getting rid of our auth and our business logic and our data access layers, where exactly do those things live? Well, they actually live inside a command or query. And that may seem confusing, but when I talk about, for example, the data access, is most of the times in our repositories, we had methods that were only ever used in one place. There wasn't a lot of shared code of methods for fetching out a product, for example. Most of these things were individualized, and maybe some things were shared, and you can deal with that still in this way, but the idea being is that each one of those responsibilities can be handled within the concept of a command or a query. So instead of having layers span your entire application, really you can have layers within your actual unit of a command or a query. All right, moving along. So let's talk about how we can do this. So the first way that I kind of got around this was with the Mediator pattern. I didn't even know what the Mediator pattern was till much later. However, I implemented it in, I think this happens a lot where you implement something and then much later you realize, oh, this is actually a named pattern and There's some things that you never thought of, but the mediator pattern is what I started using, and it's served me well since. And what it is you are basically defining an object that encapsulates how a set of objects interact with each other. So instead of one object directly calling a method on another object, you're basically going to be throwing the mediator in between. So again, if I have object A here and there's some method on object B, I don't invoke, even if I have dependency injection, etc. I'm not taking a dependency on object B. I don't want to call object B directly. What I want to be doing is talking to the mediator. So what this does is I have a dependency on the mediator, and I create a message that I can send to the mediator. And that mediator object then will know how to, where object B is, how to construct object B, and send that message along. So what are messages? We'll get into that because you can start thinking of methods calls as messages. And I'm going to start getting a little bit around some terminology here because there's a little kind of similar words that to me mean the same thing. So I've written a few mediator libraries for various projects over the years, and I've just straight given up because Jimmy Bogard created the Mediator Library in .NET, and it's served all my purposes now for the last couple of years. He's working on V3, which adds some really cool new features that they're trying to think of doing. So all my code examples here are going to be using the Mediator Library. I think it's been really picking up this library. Jimmy also created AutoMapper. So if you're familiar with AutoMapper, Jimmy's the man responsible for that as well. All right, so the code samples I'm going to be showing here, as well as all the series of blog posts that I have, if you want to look up later, are all based on the ASP.NET MVC Music Store. So what I was looking for, because I didn't have any code that I could release for example purposes, I decided I'd pick an open source kind of demoware application that I could convert that was kind of doing things in a typical way that you might expect. And the ASP.NET MVC Music Store app was doing that. The controllers weren't fat by any stretch, but they did have a lot going on in them. There's data access, there's everything that we talked about. It's not layered so much as it is just everything being in the controller. So this is also an ASP.NET Core, which I thought was really cool to take a look at. So I'm going to be using this as the example. So one of the things I mentioned was thinking of a method call as a message. And these three words to me are synonymous with each other. So I may use them interchangeably, and because mediator calls most things a request, and I call things a message, and then because we're talking about commands and queries, a query is a message, it's a request, they're all the same to me. So if I use any of these words or any of these words are in the slide, they're really all the same thing to me. So this is how Mediator works. It's exactly how the Mediator pattern works. The Mediator library works in this way. Is we have a query, which is going to be an object. That object will be passed to the mediator. And what the mediator will do is it will construct the class that's going to represent how we want to handle that message. It worries about constructing that class and figuring out which one it actually is through interfaces. And then it passes our query, our message, to a method within the handler. So what I'm going to do for the example here is we're just going to start with a simple query. So again, a simple query is returning state of the system. It's not mutating state, it's just query values. It's returning some value of the state of our system. So with our MVC Music Store app, we can take the home controller and let's look at the index action. So that was the initial screenshot that I showed. It just shows some albums listed on the home page. So if we look at this index method, there's a couple arguments here for the music store context, which is the entity framework context, and there is an in-memory cache, and both of these are using the built-in dependency injection. hence that from services attribute there. So there's that. We have what it ultimately does is checks the cache to see if the list of albums exists, the top selling albums. If it does not, then it goes and fetches them out of a method we have here in this controller called get top selling albums async, which it then passes the DB context to and fetches out the top 6 albums. Then what we have is it's setting it in the cache and then returning, passing that to our view rendering, which is then gonna, pass that back to MVC with our rendered view. So this is pretty typical, I think, of most MVC applications. If you have everything in your controller actions, this is pretty standard, right? You have your data access and pass that to your view rendering, and that's the end of it. So this isn't really getting out of control fat, but depending on how many actions you have and what other logic you have, you can see how these can start getting out of hand. So the first thing we need to do when we want to start using Mediator and moving into commands and queries is identifying what in these methods are dependencies on MVC. Like, what is it really that MVC is doing for us? The way I think of MVC is, or ASP.NET, MVC, Web API, etc., is let it do what it's good at, which is it deals with the routing for me. It's my HTTP front end, but it's not my application. So really, I just want to be able to leverage the pieces that it has, such as the view rendering, the routing, the arguments that it's passed to me, the HTTP context, post data, etc. That's the stuff that I care about. The rest of my code I want to segregate and I want to decouple from MVC. So if we look at this method again, to identify what we really care about, yes, there's the route and there's a dependency injection, etc. But I don't really need that for MVC. We can use DI elsewhere. So the only thing that MVC is really giving us right now, besides calling this method, is doing our view rendering with Razor. So we just got to get our list of albums from the database and return that to our view. And that's really all we care about. So everything not highlighted in the body of this method is really our code. And so why do I want to live in a controller? So with a query in Mediator, let's get this out of here. So again, a query. What is a query? A query, again, like I said, is a message. And in our case, is just going to be a class that we're going to pass, but once we construct, we're going to pass to the Mediator. So a query looks exactly like this. A simple query anyways, for our home action here, is we're creating a class that we implement the iasync request. And that is provided by Mediator. And it has one type parameter, which in our case, since we want to be returning, and again, our query is simply about returning state, is we want to return a list of albums. So that's what we were doing with our DB context. So that is going to be our message, our query. That's as simple as it gets. So the other piece to the puzzle here is creating a handler. And what a handler is it's responsible for accepting that message, that query, and using that query to then return the values that we wanted. So let's take a look at what that would look like. What we're going to do is create a home handler that's going to implement from Mediator the iasync request handler. And it has two type parameters. It has the first type parameter is the request, the query that we're going to be accepting. And the second type parameter is the result, the return value from what our query is supposed to return, which we define as a list of albums. So I have a constructor that's just taking dependencies on, doing some dependency injection on our database context, our in-memory cache, just like our method did, as well as some options or application settings that we've defined that we need to pass in. So then in our handle method that we have to create, that we have to implement, basically what I did here is I literally cut and paste the code from the index method in our controller, and I pasted it here directly. It's that simple because we had no dependencies anywhere in that code on MVC. It was just straight our code doing data access. So I've kind of truncated some of this just so it fits on one slide, and hopefully everybody can see it, hopefully you can see it well. But it was just really that easy as cutting code from one place and moving it to the other. So we have a query that is a message. It's simply a class that we define, given it a name and telling it what the result is that we expect from it. And then we've implemented a handler that will fulfill that request. So if we jump back over to our home controller now, and we look at this index action, this is simply how skinny down this thing can get. Is we're going to make a new instance of our home query, that request that we created, and then we are going to pass that to the mediator. So we call send async, and we pass that new instance of home, and what we're going to get back from that is our list of albums. And now that we have our list of albums, we can use our wonderful Razor view to pass that albums to it and have it return that rendered view. So again, we're just using MVC to render the view. The rest of it, we're just using Mediator to send a request off to our handler to get our list of albums. So let's do the same thing for a command. And again, a command is for mutating state of our system. That's it. So same kind of terminology here. A command is a message, is a request. Just like a query is a message request, the command, same idea. Except this time what our command is going to be telling our system is to mutate state. So in Mediator, there's really no difference between, in the library itself, between a query or a command. That's why everything's just called a request. But for the sake of understanding that a command is mutating state and a query is not. So for the example here, I'm going to be using, in the cart controller, there's a method called add to cart. So this is adding an album to your shopping cart. So what this method does is it fetches the album out of the database. It then gets the shopping cart from this static shopping cart class here, which it's using the database context as well as the HTTP context. It then adds that album that we fetch from our database into the cart, and then calls save changes on the database context, does some logging on this logger, and then redirects to the index action. So our same type of process here we would want to do as we did with our query, which is we want to identify what is MVC doing for us. Like what is it doing? It's our HTTP interface. So what exactly in this code do we actually care about? Like what's coupling us to MVC? So obviously when this method gets invoked, there's a couple things it provides for us. The album ID is a part of the URL path, and that's going to get set to our ID parameter in the method. So that obviously we care about because we want to know what album ID to be adding to the cart. The second piece to that is our HTTP context is being used to actually get our cart. So behind the scenes here, we have code in that get cart that's basically you getting the cart ID from the session. And that's ultimately what's pulling it out of the database to get our cart. So we care about getting our cart ID. So the two things we really care about right now are the album ID and our cart ID. And then lastly, the thing that, again, MVC does great for us is the HTTP end of it, which is sending back a redirect to our index action via header, via location header. So those three things are the three things that I want to leave in here. And the rest of this code, the data access to fetching the album, the getting of the cart, the adding the album to the cart, saving changes and logging, that I can rip out because I don't want in our controller. So let's take a look at how we would do that. So the command in Mediator, like I said, everything is a request, whether it's command or query. The difference being with with a command, not always, but most of the time I'll apply it this way, is that it's not going to return anything. So we're going to have a class called add to cart, which is going to implement iasync request, and it doesn't have a type parameter there. And then I'm going to have a constructor that's going to take in the cart ID and our album ID, because those are the two things that I really care about when I start implementing our method here. Those two pieces of data that I need. So oftentimes when you start looking at a request, you can think about this request, this message, as the properties that it's going to contain. You could often think about as what the arguments on a method might be. It's a similar type of idea. So instead of calling a method and passing parameters, you're creating a message with those parameters and sending it to the mediator. So those are the two pieces of information that I really care about. So here's our handler that we have to implement, and it with Mediator implements the iasync request handler. And there's two type parameters, just like our query. Is the first one is what is our request? What's our command? And the one we just created was called add to cart. The second type parameter is what the result is going to be. So just like with our query, we were returning a list of albums. In this case, because I'm not returning anything, Mediator has a type called unit, which is basically represents a no result. So I left out the constructor, but it's doing the same type of thing as the query handler did, which is it's taking our dependencies. In this case, we need a dependency on the database context as well as our logger. So same type of idea here. I've literally, this code is for the most part exactly the same as the code in which was in our controller action. So I've literally cut and paste for the most part this code into the handle method. The difference being is that our getCart no longer needs a dependency on the HTTP context because we just want to pass it the cart ID. Other than that, everything's pretty much the same. So we are fetching our album out, we are getting our cart based on cart ID, we're adding our album to that cart, saving our changes, and then logging that information, and then returning unit.value, which is essentially our no result type. So again, if we jump back to the controller action for add to cart, we've simplified it down greatly here. So again, we need our cart ID, which we can do with the HTTP context. So now we can get our cart ID out, and we can create our new instance of our command, our request, which is add to cart, and we have to pass the cart ID and our album ID, which is coming from our method parameter up there, which is via the URL path. And then once we have our command, we can send that to the mediator. And we're not expecting a result, so we don't need to assign that to anything. And then again, same idea here is that we have a redirect to action. That's what MVC is for, doing our HTTP stuff. So that's going to send back the location header to redirect to the action path. So that's as simple as a command and query can get on how you can extract some code and have no dependencies on your framework, and separate that code so it's just your code. So there's one other thing that the Mediator library can do that I want to show, that if you're looking at the example, you might think, eek, like there was some logging there, and that looks horrific. That probably shouldn't be in our add to cart command. Like, what does logging have to do with anything? So let's jump back to that slide and look at this method again. Is that we had some logging of information. You could say, well, okay, again, logging, is that a separate responsibility? And yes, it is. I mean, this is a simplified example. So I just want to show another cool feature of the Mediator library and how we can deal with things like this. So when we're talking about commands and queries, a command and a query in a request always have one and only one handler. So when we had our add to cart command, it had one handler. When we had our home query, it had one handler. There's also the concept of a notification, which you could think of like an event, and you can publish events. And the idea being is that you can have 0 or many handlers for a notification. So a notification is the same concept. It's a class that we'll create an instance out of that we will send to the mediator, and then the mediator will invoke 0 or many handlers that are accepting, that are looking for that request, that message. So we can use notifications to actually deal with logging. kind of after the fact, after we've actually created and actually invoked add to cart. So what that looks like is creating a class called album added to cart, something in the past tense, something that's happened, because this is going to be invoked after we've actually saved our changes, just like it is in code. And our logger, really all it cared about was the album ID. So we're going to add a constructor, add a public property that just with a getter, read only, that has the album ID. So this is a simple notification message that's specifying that something was added to the cart. So we're going to create one handler for it that's going to deal with our logging. So in Mediator, there's the interface called iNotificationHandler, where we're going to accept our type parameter, which is going to be what the notification is that we're accepting. And then our constructor here, we're going to be injecting the logger, which then ultimately means we can get rid of this out of our add to cart handler. So now the logger is being done here. We have our handle method, which is basically a cut and paste again of that line that was in our add to cart handler, and now it's basically here. So if we jump back over to our add to cart handler, we can now publish that new event that we can create. So I'm going to be specifying the mediator publish album added to cart, and I'm going to be passing the album ID in that we just added, and then that will invoke the handler that we just created. So you can see how we're getting responsibilities out, stuff that could be happened after the fact that you want to notify other handlers about, such for logging, sending emails, whatever the case may be. Again, this is all done in process, so you need to be aware of failures through notifications and handlers and how you want to deal with those. But they're all done in process, and it's just an easier way to kind of separate your code. So one of the things that kind of stemmed once we started using commands and queries and notifications in this way was we were thinking of code as commands and queries, but we were still organizing everything in layers. And I think that's just the nature of kind of being in the history of having code by layers and organizing it that way, which it took a long time to actually kind of identify that I wasn't coding this way anymore. I wasn't coding by layers, but I would still be organizing everything by layers. So one of the pain points I had before was making a change and having all these files open was still, this didn't actually solve it yet. I mean, it did to a certain degree because we would have everything in a lot of stuff in one file, but you still kind of had a controller over here. You still had views over here in a particular folder, and stuff was kind of disjointed and it really wasn't organized together, even though mentally we thought of it that way. Our code didn't reflect that. So when you organize by layer, our MVC application looked something like this. We had an MVC, we had a controllers folder, we had a models folder, we had a views folder, view models folder, etc. If you had any other services, etc., everything was in its own layer. But again, we're not actually coding that way anymore. We're coding in commands and queries. So if you wanted to make a change, let's say to something on the shopping cart, this is kind of what the project structure looked like. I have the solution open on the right here of our music store, and all the controllers are grouped together, models, etc. So if you're making a change to something to do with the shopping cart, these are the files that you would have open. You'd have the shopping cart controller open, the view model open, the shopping cart data entity framework model, and the view. These are the 4 files you would have open in order to make a simplistic change, which isn't so much necessarily that you have 4 files open. It's that navigating through your hierarchy or searching for these files and just the number of them that you have gets a little tiresome. So one way to work around this was to organize everything by feature. And a feature can be as simple as a command or query. A feature could be, oftentimes, maybe it's a command and a query together, side by side. Maybe it's a couple of commands or a couple of queries, whatever your unit of what a feature needs to be. But it can be as simple as a single feature could be a query. An example of that is just a report. If you're creating a query that was a report, that could be a feature on its own. So instead of organizing by layers and having controllers together and our views sitting all together, why not organize everything and put them all in a file structure that that they're related to an individual feature, such as command or query? So with our shopping cart, this is kind of what I did, which was in ASP.NET Core, you can do this, is organize and specify where your views are. So there's nothing stopping you from putting your controllers all over the place. They do not need to be in a controllers folder. They don't need to be, you can put them essentially wherever you want. So in the case of our add to cart, I moved everything into one file. So our get cart, our add to cart, or remove from cart, everything is located inside of one file. Our controller, our command handler, our logger, all of that is actually within one file. You're still going to have things that are going to be shared across various features, such as your data models, your entity framework models, and that's fine. You're not going to get around that, and you're going to have some, shared responsibilities, shared code, cross-cutting things across various features. But the things you can put together, I tend to put together. Again, because if I'm asked to do something and I need to change something in the shopping cart related to the shopping cart page, getting the shopping cart, I can essentially almost go to one file and get everything I need there, or at least go into one folder and see the get cart class as well as its view sitting right next to it. So just as a code snippet here, this is actually what you would see in Visual Studio in the MVC application that I have, which is I have the add to cart handler, the notification, the event, the album was added to the cart, and its handler, all within the same file. I don't separate these into separate files. I don't put them into different folders. They're all contained within one file. So again, I just find this so valuable, especially when you start working, if you're working in a larger team, you're not stepping over each other's toes as much as you were within layers when you start working in this way. So mentally, I start thinking of our features and our commands and queries like this, which is now MVC isn't the entire world to me. It's really just the web component, the HTTP component to my application. When you look at your application, and I'd be curious if you do this, if you open your solution and you look at your web application and you look at the folders and you look at the structure, if you had somebody come in that was brand new to your organization, could they actually tell what feature set and what use cases your application provides, other than seeing home controller and account controller? Like what actually, I find that it's so vague when you're basing everything based off of how the structure, your file structure should be in separating layers versus if you separate in features. So I just think everything is kind of lost when you're organizing by layer. So when I organize by feature, I really think of ASP.NET as this thin layer on top of my actual features. My features are the things that I care about. I don't care about MVC. I care about the value that I'm providing through what problems I'm trying to solve. And most of the time, MVC is just the mechanism for I/O. It's just an integration boundary. That's it. ASP.NET MVC could be replaced with, which I'll talk about in a second, other things. That could have been, in my case, it also could have been a WinForm application, a WPF application, whatever. So I have features. That's the things I care about. Yeah, I'm going to have some shared stuff like a data model, a domain model, whatever the case may be, databases. But again, the heart for me is everything below ASP.NET MVC, whatever that top layer is for me. So here's the things that I've experienced and that I've benefited from by doing this. This is a conversation on its own, and if anybody's interested, we can have this conversation afterwards, which is we moved from ASP.NET Web API, because we are predominantly just creating a Web API, to Nancy. Nancy fit better for us. If you're unaware of Nancy, I highly recommend checking it out. And that change with implementing Mediator and having everything as commands and queries and thinning our controllers made that transition incredibly simple. Having one file or a minimum number of files per command or query, including your controller, in that file, again, simplifies life, simplifies searching for files, makes it easier for change. You're not stepping over each other's toes and having a lot of merge conflicts because you're usually in one file, one feature, if one person's working at a feature at a time. So that has helped greatly. And the other one that I think took longer to kind of realize through the process is that concerns that you may take that are shared, that you may take between a query or command, can be removed within a query or command. So for example, if you're using Entity Framework 6, and maybe you want to be using Entity Framework, you want to move over to Entity Framework Core, or maybe you want to use the Dapper or another ORM, or you're switching something else entirely out, you can decide that per command or query. And it doesn't have to be a massive rewrite of some repository to do this. You can slowly migrate commands and queries one at a time without having some big bang of making these changes. So that one has also helped greatly for us. So the key takeaways for me in this whole process has been to segregate our code from our framework. It's what my app, I'm not creating a web application. I'm creating an application for a specific set of problems. Yes, I'm using a web framework to deal with the routing and all those other goodnesses and our views, etc., for rendering that I don't necessarily need to do. Why would I want to deal with those tasks? I can focus on the problem at hand and have my code be my code and not have Entity Framework or MVC or whatever the framework is get in the way of that. So doing so is using Mediator and the Mediator Library between integration boundaries. So our integration boundary is MVC is our framework and our application, and decouple that as much as possible. And for us, that was using the Mediator library and sending requests and messages across that boundary. And lastly, it's feature slices and not layers. It's thinking about features and commands and queries as vertical slices rather than having layers and projects that represent a particular aspect of your application, whether it be data access and business logic that span the entire application. It's thinking of things vertically as individual features and working within that particular unit. That's it. Thanks. I appreciate any feedback. If anybody wants to get a hold of me, you can tweet me at CodeOpinion or visit my blog at codeopinion.com. I have, again, a lot of these sample codes as well as the GitHub fork of the MVC Music Store app available. Thanks again.